This is a quick review of kinetic and potential energy. Kinetic energy is very easy to understand. This is energy of motion. Anything moving has kinetic energy. And the faster it moves, the more kinetic energy it has. If that car would slow down, it would have less kinetic energy. Potential energy is stored energy. So if you notice, when this starts over, she's going to stretch the rubber band. In that split second where she's not moving, just holding it stretched, it has some potential energy there. As soon as she let it go, it turns back to kinetic energy. So while it's moving, it has kinetic energy. But in this case, it had potential energy because rubber bands are elastic and she stretched it. So while she's holding it there, stretched, that's when it has potential energy. It's not moving, but it sure has the potential to move as soon as she lets go. Archery is another example. Notice, in order to send the arrow moving to give it kinetic energy, she has to first stretch that bowstring. She pulls it back and stretches it. Now she could hold it stretched there as long as she wants. It has potential energy while she's not moving, but she's holding it stretched. As soon as she lets go, we're right back to kinetic energy. Here's an example of an archery fail. Notice he pulls the string back, but he doesn't really stretch it. He just pulls it back a little bit. So he doesn't give it much potential energy. It's not really stretched. There's very little potential there. As soon as he lets go, it just falls. So he gives it a very little bit of potential energy, and he gets a little bit of kinetic energy. It moves, but not much. So a lot of things have potential energy because of elasticity and stretching, but what's actually more common is this, gravitational potential energy. Gravitational potential energy is also not moving and stored energy, but this is stored energy due to gravity. Anything that is higher than the ground has the potential to fall. Gravity could pull it down. Now in this case, the cats are helping things along. I don't think the bottles would fall all by themselves, but with a little push from the cat, it doesn't take long for gravity to just take over and pull them down towards the ground. So anything higher than the ground has some gravitational potential energy, the potential of gravity. So think of it as stored energy. Somebody had to put those bottles on that shelf, so somebody had to use kinetic energy to move it up there. Well, that energy is stored, and with a little push, it falls back down. Here's another example of gravitational potential energy, probably a more dramatic one. Notice all of those really tall shelves. The higher something is, the more potential to fall. So there's a whole lot of gravitational potential energy here. And when that forklift gives it a bump, doesn't take long for that gravitational potential energy that's stored in those shelves turns into kinetic energy and it starts moving. Keep in mind, before it moves, it had potential energy. Soon as it starts to move, it's turning to kinetic energy. A roller coaster is a great example of gravitational potential energy as well as kinetic energy. It has both, sometimes half and half, sometimes more of one, sometimes more of the other. I want you to think about where the roller coaster would have the most potential energy, specifically gravitational potential energy. Where does it have the most potential for gravity to pull it down? If you said the highest points, you're right. Right here at the top of this hill, that's the most gravitational potential energy. Let's say the whole thing collapsed. It would fall from here to the ground. That's a long way. The top of this loop would also have a lot of gravitational potential energy. What about right here at the bottom of the hill? Does it still have gravitational potential energy? Well, maybe a little bit, because if the roller coaster collapsed, of course it could still fall, so it could go from here and fall to the ground. But mostly, as long as it stays on the track and nothing collapses, mostly at this point, there's really no potential to fall. So what we really have here is kinetic energy. It's going to be moving really fast. Think about it. If you've been on a roller coaster, you go slow, 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 slow up the hill. Then as soon as you get over the top, fast down the hill. Slower, fast down the hill. Slower, fast down the hill. So as you're going down, you go faster. Your potential energy turns into kinetic or moving energy to make you go faster. Let's go ahead and look at that in a little video. There we go. So here we are back at the beginning. Notice at the top of the hill, little kinetic energy because it is moving, right? But moving slow, mostly potential energy. Let it go a little farther as it goes down the hill. Notice how we have less potential energy and more kinetic energy. If I let it go a little farther, notice here we have lots of kinetic energy, not a whole lot of potential. There's not very far to fall. What do you think is going to happen when we get to the loop? Let's see. Notice as we come to the top of the loop, we have some potential and some kinetic. When we get to the actual top, notice how we have about half and half. You must be moving pretty fast to make it through a loop and not just fall down. So I would expect a good amount of kinetic energy, but it also has a lot of potential, the potential for gravity to pull it back down. So I'm going to go ahead and let it play through again, and I want you to notice how potential and kinetic energy change. Notice how it speeds up going downhill, and it slows down going uphill. Lots of kinetic, potential, lots of kinetic, potential, lots of kinetic. All right, that is it. That is all I have for you. So hopefully that helped you to understand a little bit more about kinetic and potential energy. Just keep in mind, kinetic energy is movement. Potential energy is not moving but could move. Sometimes, like in the roller coaster, you may say, hey, it was moving the whole time, but it also had the potential when it slowed down to get faster as it falls back down. So it had the potential to move faster, the potential for gravity to pull it down.